Okay, so here it is. The one that everybody dreads, empirical molecular formula. I don't know how many more times I can say it, but so there's a couple different problems that you're dealing with. The first type of problem is where they give you the molecular formula, and they tell you to find the empirical formula. Um, and if they do that, there can't be any common factor in the subscript. So like you've got C2H6 here. I can factor a 2 out of that. That's what I always try first, is to factor a 2 out, and generally that steers me okay. If I factor a 2 out of C2, then it is C, and if I factor a 2 out of H6, it is 3. So I have CH3. Um, Factor out that 2, giving subscripts of 1 and 3. And therefore CH3 is the empirical formula. 6 divided by 2 is 3. That's what I'm showing you there. 2 divided by 2 is 1. 6 divided by 2 is 3. Therefore, the empirical formula is CH3. All you got to know is that the empirical formula can't be factored anymore. Like the subscripts can't be factored. So if you see a 1, there's no common factor of 1. So you know that's empirical. Now, the one that really gives you fits is when they ask you to get an empirical formula or get a molecular formula from an empirical formula in which they give you the mass. So let's do this. I have a compound with all these percentages in it. So the first thing I have to do is hecto percent turns into grams. Hecto. Those percents are now grams. The second thing I have to do is convert grams to moles using dimensional analysis. So like I said before, this is not a number of boxes. This is just dimensional analysis, crosses, and I don't have a lot of room here, so I'm going to try and cram all this in here. So I have, wait a minute, that's not going to fit really well. Let's use less room. How about that? Here you get to see me erase. I could just redo this video, but I don't want to do that. I'd rather just sit here and erase. Make you watch the whole video while I erase it. Okay, so let's just see how much room we do need. I have 21.2 grams of oxygen. Oh, sorry, nitrogen. And I'm going to convert that into moles of nitrogen. And then I'm going to have grams of nitrogen. So that is 14 grams. And notice I'm not using the molecular formula. I'm not using N2. That's because this is already in a formula. So I'm not using N2 to determine the number of moles here because I don't care that it's diatomic, that it forms an N2 when it's by itself. But because it's not by itself, it's with hydrogen and sulfur and oxygen. Okay, in 1 mole. So 21.2 divided by 14 equals 1.51 moles. Moles of nitrogen. All right, now we're going to. Next guy here, 6.1. This is 6.1 grams of hydrogen. There's 1 gram of hydrogen in each 1 mole of hydrogen. So that equals 6.1 moles of hydrogen. 24.2 grams of sulfur. And that is grams of sulfur and 1 mole of sulfur. And that number is 32. So 24.2 divided by 32, enter, 0.75 moles. Sulfur, oh man, I'm running out of room. Now I've got 48.5 grams of oxygen, 16 grams of oxygen per 1 mole of oxygen. I'm going to have to put this answer down here. Anyway, 48.5 divided by 16, 3.03 moles. 3.03 moles of oxygen. Okay, so then you're dividing dividing by the lowest mole total. Well, I have 1.51 moles, 6.1 moles, 0.75 moles, and 3.03 moles. Obviously, 0.75 moles is my lowest mole total, so I'm going to divide by that. That obviously means that S is 1. Okay, let's do 3.03. 3.03 divided by 0.75. Okay, I get 4.04. That is in the hundredths place off, so I'm going to round that. I cannot round it if it's tenths off. So if it's 4.1 or 4.2 or 4.3, I got to think of a different strategy. Hopefully they won't give you anything like that. Okay, so I have, it's 4, and then 6.1 divided by 0.75. See, here's the problem. 8.133. I didn't really look at this one, but God, that would be awful. I think we're just going to make it 8. We're going to call it 8, even though it's a big fat lie. Hopefully the rest of these guys turn out right. So that is H8. And 1.51 divided by 0.75 looks like a big 2. 2 and 2 and 2. So it looks like I have N2 H8 SO4. N2H8SO4 is my empirical formula. Now, the only way to get a molecular formula is I have to have a molar mass, and basically it is molecular formula mass. I always just put it as MFM over empirical formula mass, and whatever that is equals is the factor that you multiply all the subscripts by. So if they gave me a molecular formula mass, and let's say the mass of this empirical formula was 200, and they gave you a molecular formula mass of 400, 400 divided by 200 would be 2, then I'd multiply all these subscripts times 2. So this would be N4, H18, S2, O8. And that's what you're doing. That's basically what you're doing on all of these. If you follow these steps, it's basically just a step-by-step process. So the first process, now there's an extra step in this one, because they're giving you that 60% is carbon, 13.4% is hydrogen, and the rest is oxygen. Well, 60 plus 13.4, enter, and then I'm going to 100 minus that answer. So that looks like 26.6% is oxygen. So that is my tip to you. 26.6% was due to oxygen. So you're going to do the same steps that we did up here. Let me know when you get some answers for those 3. This one's going to take you a second, but show me your answers, and I'll tell you if you're right or wrong.